The hydraulic press, since its debut in 1795 when it was patented by Joseph Bramah, has been a very popular and powerful tool in manufacturing. But it is expensive. Most budget options listed online will cost you anywhere from $80 to $2,000 and are often limited in size, features, and applications. What if there was another option? An option not only affordable, but packed with features and large in size. Drum roll, please. Introducing the Dead Loader! At around $80 for the entire build, we were able to replicate the purpose of the hydraulic press in a new and inexpensive way. Now before we can go breaking stuff, we have to talk about how this works. I'm going to hand the mic over to my buddy Aaron, who's going to show you the ins and outs of how the Dead Loader works.
Hey guys, what's up? Actually, I think I'm missing something.
Lab safety.
Alrighty guys, now that we have our safety equipment on, we're going to go through the dead loader and see exactly how it works. Starting here at our winch, you can see that we have our power drill, turning the small gear ratio to eventually turn the coil of metal wire. This metal wire goes through that hole right there at the bottom to a pulley that's stationed directly in the center, and that pulley then leads that metal wire straight up to the top where it meets the Newton meter. As you can see, the Newton meter is connected to the material using the collar that you see at hand, while still making the Newton meter visible.
Awesome. Thank you, Aaron. So now I think we're ready to start testing. We've gone over the purpose, we've gone over some background information, and the components. So now, what are we going to do for our test? So here you see we have 4 different materials: plywood, acrylic, PVC, and ABS. In order to test this, we are going to have 3 tests for each type of material. Then we're going to take the average load it takes to break each material. We've included PVC, even though PVC will not break in our tester. We've included it to show you that some materials will not work in our tester and that there's much room for improvement. We plan to improve it in the future. We did make a slight modification on the fly by adding 2 bolts to the end of each material. This would stop it from flexing so much that it would fall through rather than fracturing. The 4 materials that we had chosen were not random. We chose ABS and acrylic because they're fairly similar in elasticity, PVC because we knew its elasticity would be the highest, and wood because its elasticity would be the lowest. This would give us a good range of data that we could compare and see the differences in, to demonstrate the capabilities of our machine. At the higher end of the spectrum, you have PVC, which likes to flex, which means it takes more force to fracture it. Wood, on the other hand, takes much less force since it's a much more rigid shape, and acrylic and ABS don't take as much force as PVC, but a little bit more than wood, and they're about at the same level. And with that said, I think that about wraps it up. This challenge was not only entertaining, but it was a great learning experience for me and my partner Aaron. We'll be sure to do this again next year. I would highly encourage anyone who loves to get creative and build stuff with their hands to try out this challenge. And with that said, thank you ASM, and thank you me. I'm awesome. And Aaron too, I guess. Yeah. Thank you, Aaron.